Look at example 1, read it, and let's talk about how this boy came up with this number so fast. You read it on your own. How did the kid add up all of these numbers so fast? He's a nerd. I mean, think about this. You have this kid, and the teachers say, take 1, and 2, and 3, and 4, and 5. Add them all the way up to 100. And he said, oh, ta-da, it's that. Would you guys be able to figure out how to do that? Google, sure. But at this point, you guys don't have information how to do that. But that's what a series does. A series is a fancy way to add up numbers. Now, we're talking arithmetic series. Remember from last time, what's arithmetic? It's a list of numbers that are adding or subtracting. There's a pattern of addition or there's a pattern of subtraction. That's arithmetic. So then what you are going to do is you can look at this pattern of these numbers and you can add them all up, and that turns it into a series. So let me show you a couple examples, then we'll come back up and actually show that we can do that. So a sequence, let's say we have 3, 7, 11, 15. Can you guys recognize the pattern with that?
Yes.
Good, the common difference is 4. Perfect. Oh, sorry, I shouldn't put the dots. I wasn't paying attention. But what if I have 3, no, actually, let's do this one. Let's do 5, 7, 9, 11, 13, 15, and so on. Can you see the pattern with that one?
2.
Yeah, the common difference is 2. Now, what do you notice about these two? This one is considered a finite sequence. This one's considered an infinite sequence. Who knows the verbiage of that, finite and infinite? Amen? Do you have an idea of what that means?
Finite has an end.
Yes.
Infinite has no end.
It ends. And this means it never ends. So with this one, could you continue to go on and on and on and on forever and ever and ever? That's what these little dots mean. It goes on forever. This one means it just ends. It's finite. So now how can we make this a finite series? Remember, a sequence is a list of numbers. What's a series? Adding the list of numbers. So we could do 3 plus 7 plus 11 plus 15. What does that equal?
26. No, 36.
26, 36. So this is a series where you take the sequence and add them all up. An infinite series, you can do the same.
But you do it for, oh man, that makes no sense. Forever.
Yeah.
So how do you get an answer from a
So
sequence?
next week we'll learn about geometric sequences and series. Infinite series for arithmetic cannot be, they never end. They turn to infinity, but geometric, they'll converge to a number, and we'll talk about that. But I just want you to see the difference between infinite, that goes on forever, finite, that ends. Okay? So there is this formula, and we'll write it up here. If you want to find the series of a finite amount of numbers, so a series of a finite amount of numbers, n. So if there were 10 numbers, the n would be 10. It actually is going to look like this. The first plus the last divided by 2 times n. That is how you can add up all of these numbers. This is the formula. So this cute kid, where he was like, oh, I know how to do it. What's his first number in this series? One. What's the last number in this series?
100.
Good, 100. How many numbers are there?
100 numbers.
There were 100 numbers. Now, actually, I think there's 101, isn't there?
No.
And the way to find it, let's find out how many. To find n, first, take the last, subtract the first, which is 100 minus 1. And then you do 99 divided by the common difference, which our common difference for this one is 1. And then you take that number and add 1 every time. So there are actually 100 numbers. Sometimes that confuses me because I'm like, do you count the 100 in the one spot? Anyway, so there's 100 numbers. We're going to come back to this idea again and again. We'll do this over and over. You have to be able to find your n to plug it in there. So our n is 100. And so to find this number, s of 100 equals 100, 1 plus 100 divided by 2. What do you get? Put that in a calculator. This right here. And that whole thing is divided by 2. Yeah.
I'm looking at your steps, and on number 2 it says 99. Is that D?
Yeah, the common difference.
It doesn't look like D.
How do I make it look like a D?
Just shave off a little bit off the bottom.
The bottom. Okay, I could do that.
I got confused.
Is that better? Okay, what do we get? Did someone put this in the calculator? What number is it? 1 plus 100. So 101 divided by 2 times 100. What do we get? Yep, times 100.
Times 100.
50-50. Is that how the kiddo got it? What? Is he so smart? He knew the sum of an arithmetic sequence is using that formula. Boom, you can add it up. That's incredible. Isn't that incredible that you can do that? Add up every single number? I love it. Let's try it for this one.
This can actually be useful.
How can this be useful?
Okay, look at example 2. Let's try to do the same thing. The first 4 rows of chairs are set up for a meeting. The first row has, so this is row 1. The first row has 4 chairs. Are you okay if instead of saying row 1, I say A sub 1?
No, I'm not okay with that.
We're going to do it anyway. A sub 2, which is row 2, is 6,
Oh, A sub, that's what you're saying.
and so on.
I thought you were saying like A sub one.
And it goes on all the way till row 15. So it's going up by 2. So you have to remember, this is still an arithmetic sequence. Can you tell me the first term?
Oh my.
4. Can you tell me the common difference?
2.
Can you write the explicit formula?
Yes.
Yes, I'm certain. Wait.
Now, why would I write the explicit formula?
To find how many chairs are on the 15th.
Yeah, to find the 15th chair.
So the n would actually be 15 of the ball. 15 into the n.
Let us.
And so what is the 15th chair? How many is that?
32.
14 times 2 is 28 plus, 32. So A of 15 is 32. Now, we do need to know n. How do we solve n? So we have the 15th chair, the 14th. We know that when we add it, it's plus 2. So we needed to know the common difference. We needed to know the first term. We need to know the last term. But we need to know how many n's there are.
15, right?
Yeah, this one, we know for sure it's 15 because it's row 1, 2, 3. There's 15 rows. So n is 15.
Ms. Peck, we're out of calcs.
We are.
Anyone?
I'll have to share. I have one right here.
Share it, just share it.
So now let's use our formula. The sum of these 15 numbers is n times the first plus the last divided by 2. How many, and so it's saying how many chairs are there total, which is helpful to know. Say you need to know how many people you can invite to this auditorium. How many seats do we actually have? You can add them up that fast by this series. So what's 4 plus 32 divided by 2 times 15? 270 seats. I mean, guys, do you not think this is cool?
No.
Yes, it is. You,
Why'd you just do that? Was that extra just for fun?
Yeah,
well, it asked, how many chairs will there be in all 15 rows? So instead of saying, okay, 4 in the first, 6 in the next, 8 in the next, and adding all of them up, you can use the summation formula, and it will add them all up for you.
What?
Yeah, it's cool.
Wait, so do we need to learn that formula now?
Yes. Everything I say you have to learn. Okay, let's look at another one.
Hold up, wait.
You guys, shh, or I'm gonna bust you up.
You just stay on this slide for just a second.
Yep. Not physically, I will separate you.
It's not absolute.
Are you good?
No.
No. Okay, try number 3. They want you to add up all of the even integers from 2 to 1,000. So we have 2, 4, 6, 8, all the way to 1,000.
Oh, add them up? Oh, shoot.
Now the first thing that you have to do is just look at it as a sequence. So just go back to the original. I want you to practice, can you find me the first term? 2. Can you find me the common difference? 2. Can you write it as an explicit formula?
Yes.
Okay, so all of that's fine. We can do all of that. That's what we learned last time, is can you look at the pattern? Can you see the first term, the common difference? Can you write it as an explicit? The explicit helps you find an exact number in the list. Now, we don't have to do anything with that because we already know that the 100 or the 1,000th term is 1,000. Yes.
How do you know to go up by twos? Like, does it
Well,
say-
it's adding by 2.
Even. Of all the
It's
even
all the
numbers.
even integers. So
Oh,
even
I didn't
integers
see
are
that.
2, 4, 6, 8. No, you're good. Now, how do you find n? Remember with n, to find n, you're going to take the last minus the first, and that's going to give you 998. And then you're going to do 998 and divide it by the common difference. Does that D look better? So what's 998 divided by 2?
That's almost the key number.
Someone with a calculator. 998 divided by 2.
499.
Okay. And then you're going to take 499 plus 1.
Wait, why plus 1?
It's just, that's just the method all the time.
All the even.
That's the method?
Holy cow.
So your n is 500. There are 500 numbers in that list. So this is kind of easy to see because it's obviously 1,000 divided by 2, but what if it's not as easy to see? What if it's like every 7th number and you'd maybe feel a little confused? You don't know exactly how many numbers are in the list. You can use this method every time to find how many numbers are in the list. So now let's use our summation. So the summation of these 500 numbers, 500 2 plus 1,000 divided by 2. If we are adding all of these up, 2 plus 4 plus 6 plus 8 plus da-da-da-da-da, all the way to 1,000. That's what this is saying, is we are adding up all of these.
You didn't like write down this formula.
Well, we have it on the first page right here.
Yeah, but I like when it's like in the notes.
I got two,
You know, like
250,000, I don't even know what number that is. I'm gonna be honest.
255.
So 255,
0, 0.
0, 0. So 25,500.
5,500.
Dude, I low-key get
Two-
250,500, that's what I got.
Jeez Louise. Say that again. 5
0, 5.
250,500.
Yeah, I was gonna say that, and then I just didn't.
I mean, guys, this is incredible that there is a formula that will add up all of the numbers as long as you know the last and the first. And if you don't know the last, you can find it by using that.
you know,
Yes. You what?
Use, like, how do you put the 500 below the 2? Like, how do you use base?
So I would do 500 parentheses and then do 2 plus 1,000 divided by 2. And I got that from this fraction number. That fraction number will put something in the denominator. Oh, are you trying to do this? You're trying to do this? You don't put that into the calculator, you just put this part. Okay, try to find the sum of example 4. Ready, go. Oh, yeah. Yes, a lot. So far, all of them have been a little bit easy, like 15 rows. Well, you have 15 rows, your n is 15. Oh, or he added up 100 numbers. Well, you have 100 numbers. This one, it's 500. But some of them, like, how many numbers do you have between here and here when it's adding by 4? Some of them can maybe get a little complicated, and just so you're not off by 1, this blue method makes sure that you can find your n every time. Because this is now adding by 4, and so it can just get a little like, gosh, how many numbers would there be between 2 and 98 if I'm skipping every fourth? It's just sometimes not as easy to see that. 98 minus 2 divided by 4, which is this method, right? It's the last minus the first divided by the common difference. So it's that method. But then you always plus 1. Yeah, Alex. You did. Okay, quiet everyone. Remember, I'm recording. Shh, not so loud. Try it in example 4. So we have this sum. Whoops. What is our common difference? Yep, we're adding 4. So first term is 2, common difference is 4. We could write the explicit formula like this. We don't need it because we are already given the last term. But what is our n?
1,200.
To find n, remember you have those 3 steps. 98 minus 2 is 96. 96 divided by 4 is 24. And then 3, it's 24 plus 1. So it's 25. N is 25. And so a sub 25, because there are 25 terms, is 98.
how did you get 25?
So this is the pattern for finding n every time. You do the last minus the first. So 98 minus 2 is 96, and then 96 divided by 4 is 24. And then whatever this is, add 1 every time. So it's 25. So there are 25 numbers in the list. So our 25th number is 98. So if it ever gets tricky to find n, just use that technique. Last minus the first divided by the common difference plus 1. I don't want to do that box. Okay, so now let's do a summation. The sum of those 25 terms are 25, 2 plus 98 divided by 2. How many numbers are in this list? It's adding by 4, so it's not,
There's 1,000. Yeah, I got 399.
Well, hold on, everyone just be quiet for 1 second.
It's 1,250.
1,250. So if we added up all of these numbers, did anyone else get that?
Yeah.
Are you guys confused about why it's 25 numbers?
I got 1,250.
If the twins have it, it must be right. Any questions on this? Where are we feeling confused? Alec or Ben?
Did you use the?
Shh. Hey guys, quiet. Ben's talking.
Did you use the arithmetic formula up there?
Did I use the explicit? I didn't really use it, but I want you guys to be able to write it because you will need to remember it.
When would you use it?
Say they didn't tell you this number, then you'd plug in, well, they would probably have to tell it to you, but maybe they could ask you to find this and then find like the 5th number in the list or whatever.
So why'd you write it down?
Just for practice, just so you can still see how to write the explicit, because that's something you have to know. Carter, put that phone away, hun.
Every time my lid breaks,
Okay, try example 5. Guys, there's lots of talking. Should I do a quick switch of the seating chart? Then I need that group right there to be quiet, and that group right there to be quiet, and this group to be quiet. Or else I'm switching it up. We'll do a tech break, and we'll have a whole new seating. Try number 5. I'm going to freeze the screen. You guys try it on your own. Ben.
You always minus 2.
Where did I minus 2 from?
When you're finding the first step.
No, it's always the last number, the last minus the first. So the last minus the first. I'm going to find n first.
Star Wars was John Williams. I'm so funny.
John
Is
Williams.
the answer 840?
Yeah, John Williams is the
Well, so far all I've done is this. Did you guys get your n to be 15?
Yes.
Okay. So our first term is 7. Our 15th term is 105. Our n is 15. If we want, our d is 7. If we wanted to write explicit, it'd be 7 plus 7, n minus 1. And now we can do summation of the first 15. So the hardest part about this is really finding n. How many numbers are in the list?
I just finished writing the last.
850? 840? I don't know. I just count on you guys with the calculator. Did anyone else get 840?
I didn't.
So why is n 15? This is the method to find n. The last minus the first divided by the common difference. It's right here. Last minus first divided by the common difference, add 1.
Okay.
So last minus first is 98 divided by common difference, which is 7. And then you take that plus 1 and it's 15. So you have to know how to find your n. So Santi, can you see how this method is helpful? Because right here, would you have known there are 15 terms? Without adding them. You probably got 14 if you did this minus this divided by, I don't know. I don't know how you were doing it before, but. Okay, so you do last minus first divided by the common difference. Because that tells you how far they're jumping.
What's that A N
This right here,
Oh, that's the error.
that's the explicit.
Why is that?
Just because I want you guys to remember how to do it.
Oh,
Yeah.
What does N mean?
and is how many numbers there are. So this is saying, let's add up the 15 numbers in the list. This is saying, let's add up the 15 numbers in the list. So there's 1, 2, 3, 4, 5, there's 15 numbers.
And like, why would you do that?
Because that's just what it's asking. It's asking us to add them all up. Is that okay? Okay, sweet. Guys, let's do a tech.